All right, now we're on part 2 of test 1. In number 31, we are given that the perimeter of the rectangle ABCD is 96. So that tells me perimeter. Remember, if we're talking about a rectangle, so we have the length and the width. So we have 2W plus 2 times the length is equal to 96, and of course I would reduce that, equals, let's see, 96 divided by 2, that's going to be 48, isn't it? Now think about this ratio here, 3 to 5, as a really 3x plus 5x equals 48, because it's really just finding the scale. It's a 3 to 5 ratio. And we really need to see, well, what is that little x value? What is the ratio here as far as individual terms? And so notice we get x equals 6. Now, we want to know, well, what is the length of AB? And AB is, AB to BC is 3 to 5. Well, we know that that scale factor really is 6 here. So really we need to multiply that by 3. So 3 times 6 is going to generate that 18 for us. So B is the answer choice for 31. Okay, now looking at 32, we have a triangle ABC, and the base AC has a length of 16 inches. And the altitude is 8. The area of a certain square is equal to the area of the triangle ABC. What is the length in inches of a side of that square? So the area of a square is side squared, and they're saying that area is equal to the area of a triangle. The area of a triangle is 1/2 base times height. So my side squared is going to be equal to 1/2 16 times 8. So my side squared is equal to, let's see, half of 16 is 8. And so notice my side squared is 8 times 8, right? So S has to be 8. So 32 is G. Okay, moving on to our other problems. So for 33, we're given, it looks like a basketball court. And let's see, we have a square. CD is the diameter of the semicircle that we see down here. And let's see, point K is the midpoint of CD. Point J is the midpoint of AB. And let's see, what else? Points E and F lie on the line AB. The 3 given lengths are in meters. So we have all this information now. And so let's see if we can answer our question. The length of EH is what percent of length AD? Okay, so let's look and see the length of EH. What is the length of EH? Well, let's see. It looks like it tells us that EF, let's see, EFGH, so EFGH, that is a square. So I automatically then know that the length of EH is going to have to be 3.6. And that is what percent of the length of AD? Well, AD looks like this side's going to have to be 12 as well. So we've got 3.6 over 12. So let's see, what percent is 3.6? 12. So let's calculate that and see. 3.6 over 12. And that's going to give us 0.3. and then we need to multiply that by 100 to get our percentage. So it looks like we're going to have 30%, which is going to be answer choice B. So the fact that we were told that those were squares was very helpful. Okay, so now let's look at 34. What is the length in meters? And let's see, was it already in meters? I believe so. Okay, so what is the length in meters of JD? So let's go find JD. Oh, look at JD. That's going to be all the way across here. Oh my. So let's see. JD. Let's see if we can't draw that in. So J to D, that's going to be all the way down here. So JD. So it looks like we're going to have a triangle of sorts. Well, if we know this was a square, I know that's a right angle then. Well, that's good. And J is the midpoint of AB. So I know this side length over here is 5. So this is going to be a matter of Pythagorean Theorem. So let's see if we can't come back down here. We've got 5 and 12. So when we work that out, our hypotenuse is going to be our C value. Now the formula, a squared plus b squared equals c squared. And so 12 was one side, 5 was the other side, and our hypotenuse was our missing side. And so when you work all that out, or you can remember this is a 5, 12, 13 Pythagorean triple, and those triples do tend to come up. So here, either way you work it out, we see that 34 should be answer choice F. Okay, so now we need to look at question 35. Okay, so for 35, what is the length in meters of arc CD? So let's look at arc CD. That's going to be talking about this area right here. So arc CD is right through here. And so a good way to figure that out, we do need to know, well, what is the diameter here? And that diameter looks like it's going to be 10. And so what we can do is find the circumference and then take half of it. Now our circumference formula is going to be pi times the diameter. And so our circumference is pi times 10, but that's for an entire circle. We want half of that, so I'm going to divide that by 2. And so notice we get 5 pi. So that's going to be answer choice B. Okay, now let's look at number 36. 36, the figure will be placed in standard XY coordinates so that K is the origin and AB is parallel to the x-axis, and 1 meter equals 1 coordinate unit. So which of the following values could be the y coordinate of H? So let's see, we want the y coordinate of H, and we're going to think of K as the origin. So let's go back over and look at our figure. And again, K is the origin. And we want to know, well, what could be the y unit of, or the y coordinate of H? So right here we're at 0, 0. So goodness, let's get some of that off of here as far as racing here. Okay, so that's 0, 0. Get rid of some of this stuff. My goodness, it's a mess there. And so let's see. Here's 0, 0. And I want to know, well, what is this H? What could possibly be the y coordinate there? And y coordinate, remember, is either up or down. Well, I think it helps for us to go back and remember that we were told that EFGH was a square. So that means this distance EH, that is also 3.6. And so what does that help? Well, from K all the way up to here is 12. But if we back it up 3.6, well, then that's going to give us 12 minus 3.6, which is going to give us, what, 8.4? And so that should be the height from here to here. So I think 8.4 might be the correct answer. So let's see, 8.4, that's going to give us answer choice H. So 36 should be answer choice H. Moving along. Okay, for number 37, what is the length in coordinate units of the altitude from C to AB? So let's sketch off from C to AB. That's going to be, make this a little bit bigger so I can write on it. So from C to AB. So I want to know, well, what is that going to be? Well, let's think about this for a minute. We want to know that altitude, so from here to here, and I want to know, well, let's look at this. Well, all the way up is 4, isn't it? That's saying, hey, I've gone all the way up 4 units, but I'm already up 1 unit here. So the remaining part looks like it's going to have to be the measure of our altitude. So that looks like it's going to have to be 3. So for 37, we should get answer choice A. It looked like it might have been a little bit more difficult than that, but it's really not. Okay, as long as we know what altitude is. Now let's look at 38. And 38 is getting into those word problems where we want to skip through and glance over, and I don't blame y'all for doing that. I would look through and see what our formula is, because most of these are going to give us some terrible formula. And notice they're going ahead and telling us that e to the negative 3 is about 0.05. And let's see, and that's going to be the probability. 3 customers are in line. And let's see, which of the following values is closest to the probability that exactly 2 customers are in line? So this is really just a matter of plugging in. N is that exactly n customers. And P is the probability, which is what they're asking us. So P equals 3, and let's see, we want n is the number of customers, so 3 squared, times e to the negative 3, which they tell us is 0.05, over n factorial, which is 2 factorial. Well, 2 factorial is just going to be 2 times 1, so really I have 9 times 0.05 over 2 times 1. So let's see, what is that going to give us as far as our answer choice? So we have 9 times 0.05, and then all of that's divided by 2. So it looks like if we plug all that in our calculators, we get 0.225, and the closest value to that is going to be J. So even though that problem looked terrible, it was really just a plug-in problem, so it wasn't anything just outrageous there for us to do. Okay, so now let's look at number 39, and it's wanting to know what is the amplitude of this function. And this just goes back to our basic graphs. Our amplitude should be the number that's sitting right here. It's the coefficient of that cosine or sine, whichever that you have. And so my answer is B, is 1/2. So that helps to know or pay attention in Algebra 2 when y'all are told that. All right, so now let's go ahead and look at number 40. The license plates consists of 3 letters taken from 26, A through Z, followed by 3 digits taken from 10 digits 0 through 9. Which of the following expressions gives the number of distinct license plates that are possible given that repetition, that is important, of both letters and digits are allowed? So if we can repeat ourselves, and there's 26 to choose from, and we have 3, wasn't it? 3 letters, and then followed by 3 digits. And notice we have 26 choices here, 26 here, and 26 here. And you would multiply all of these because you're doing an and, so to speak. So you're doing and then we're still doing numbers. And notice it gave us 10 digits here. And really, we're just going to multiply all of this together. Well, let's see. The biggest problem, kids try to choose G. It is not G. No, just say no. Stay away from that mess. And who knows with all this other business. But I do know 10 times 10 times 10 can be written in exponential form as 10 to the third. And 26 times 26 times 26 is 26 to the third. This is all multiplying, so it's answer choice F. So be careful with that. Don't choose G. However, a lot of people will try it. Okay, now for 41. 41. It looks like we have some kind of table here. And let's see, what does it want us to do? We have 20 quiz scores in a typing class, which is kind of outdated. We don't have typing classes that much anymore. The table below gives the frequency of scores in each score interval. Which score interval contains the median of the scores? So the median of the scores, that's going to be the middle of the scores. So, goodness, let's see how many scores are actually here. I would go through and let's see, we've got 20, don't we? We were told 20. So let's see, this top part here we have 3, 4, 7. Well, my goodness, and then there's 9. And then 10 and 7, 8, 9, 10. So I would think right in here, because if we want the median, we're looking for that number in the middle. So it looks like from 81 to 85. So it's going to be answer choice D. Okay, moving on to 42. Anytime here for 42 we're talking about complex numbers, I squared is always equal to -1, and you would treat that just like any other problem as you're working out that would have variables in it. It's just at the end you need to go back and change anything you see that has an I squared. You need to substitute in -1. Okay, so let's see. We're going to go ahead and I'm going to say 1 over 1 plus I times 1 minus I over 1 minus I. And this is fractions. We are multiplying, and so we need to multiply across the top and bottom. Now 1 times 1 minus I, that's still 1 minus I. But in the bottom, we're going to have the distributive property because we have a binomial times a binomial. So I have 1 times 1, and then 1 times -I. And then on the inside, I have positive I times 1, so that's positive I. And then the last one, positive I times -I, is -I squared. Now let's see if we can't simplify. We still have 1 minus I on top. Now the denominators, notice -I and positive I. Those are going to cancel each other out, and I have 1 minus. Well, I squared, again, we were told that that's -1, so it's minus a -1. So that's going to be plus a positive. And so I have 1 minus I all over 2. So let's see, which answer choice, 1 minus I all over 2, looks like it's going to have to be answer choice J. Okay, moving on to 44. Okay, let's see, with 44, looks like it's going to be a difficult problem, but I think we can work around that. The table gives experimental data, values for variable x and y. Theory predicts that y varies directly with x, so that means just y equals x. Based on the experimental data, which of the following values is closest to the constant of variation? That constant of variation is this k value. So really, and they give you that equation right here, we need to see, well, how is this varying each time? That's why it's called constant of variation. So really, all you have to do is pick a point from this chart. That gives you an x and a y value, and you solve for k. So I'm just going to choose the first one here. So I have 0.140 equals 2.75 k. So to solve for k, we would need to divide both sides by 2.75. And let's see, well, that should give us our k value. So let's type that in our calculators and see what we get. We have 0.140 divided by 2.75. And so that's going to give me about 0.05. So it looks like we're going to have, for 44, answer choice G. So that wasn't too bad. I would try to use my problems here because most of us are not going to remember what that constant of variation is, or if we've even seen it, but the problem itself here gave it to us. All right, let's back up and do 43. I skipped that one. Okay, on 43, we are told that for some particular value, then our Fahrenheit and our Celsius would be equal to each other. And we want to know what that value is. So really all we have to do for this is really change out one of these variables. So if I make F or C change out to the other, well, let's just change C to F. So we have F equals 9 over 5 F plus 32. So I'm going to subtract 9/5 over. So what in the world is that going to give us? That's going to give us a negative, isn't it? 4/5. F equals 32. And now let's multiply both sides by the reciprocal, which reciprocal doesn't mean you lose your sign. That sign stays with it. And so let's see, 4 cancels into 32, 8 times negative 5, negative 40. So 43 is going to be answer choice B, negative 40. Okay, now let's look at 45. Looks like a great problem here. During a snowstorm, the relationship between the depth of accumulated snow, y inches, and the elapsed time, x hours, is modeled below. One of the following graphs, let's see, in standard xy coordinate plane models the equation for the positive and x values. Which one is it? Okay, well, let's take our equation. And I would rewrite this in y equals mx plus b, because that's kind of how this is graphed. So that just means we're going to take this equation and solve for y. So I would need to subtract my 2x over. So I have negative 5y equals negative 2x minus 5. Now you've not completely solved for y yet. You need to divide everything through by negative 5. And a lot of times students forget to do that. So we have y equals positive 2/5 x and then plus 1. Now that plus 1 is important because that's going to give us our y-intercept. That number sitting out there, that's going to tell us where we need to cross the y-axis, that plus 1 there. So let's see, A is at plus 1, so A is okay. D is not. B is okay. But notice C and E, those are all gone. So we have those two particular lines. Now, what we need to do to really get rid of the other or make a final decision here, look at our slope, 2 over 5. Our slope is what we call rise over run. And so notice the slope is 2/5. So I only go up 2 and then I go over 5. So let's start here. Let's start with A, and we're going to go up 1, 2, and then over 5. 1, 2, 3, 4, 5. Yeah, that looks like I might hit on that line. But let's try for part B just to see also. So we need to go up 1, 2, and then over 5. Notice we're not going to end up on that line at all. So this one is going to be answer choice A. Okay, now let's look at 46. With 46, this person is baking bread. The original recipe calls for 1.5 teaspoons of yeast, 2.5 cups of flour. Use the entire packet. Contains 2.25 teaspoons of yeast. And we'll use the same ratio of ingredients for the original. So how many cups of flour does Diana need to use? We can set up a nice proportion here. So we have 1.5 yeast to 2.5 flour. And we want to know what is that equal to when we want to use 2 1/4 yeast, but we don't know how much flour. And so we can cross multiply. So I have 1.5x equals, now we have to multiply these two. So I have 2.5 times 2 1/4. So let's go ahead and swap all of these over to improper fractions. So 1.5, that's 3 over 2, x equals, that's going to be 4 5/2 times 9 over 4. Okay, and so, goodness, before I start doing a lot of multiplying, I know I'm going to have to divide by this 3/2. So let's just write all of this out. So I have 5 over 2 times 9 over 4 times, now if I divide by that, it's going to be 2 over 3. And I would just go through and start canceling what I could. So those 2's I know are going to cancel. The 3 is going to cancel with the 9 leaving a 3. And so it looks like I'm left with 15 over 4. And 15 over 4, let's see, 4 goes into 15 3 times, right? With 3 left over, so 3 parts of 4. So 3 3/4. So 46 is J. Okay, so hopefully that helped us remember a lot of our basic stuff. Don't see it that much anymore. Okay, now for 47. Now 47 is a problem that people make all kinds of common mistakes on. We do need to be careful. A lot of times students want to cancel just the 12 and the 3x, and they completely forget about the 9x squared. Something to help you remember, since this is over just one term, this is really 12x to the 6th over 3x squared minus 9x squared over 3x squared also. You had to have a common denominator before you could put them all together, and that denominator was 3x squared. Now you can come over here and start reducing. 3 cancels into 12, leaving 4. Look at your answer choices, they're all 4. Now we're dividing, subtract these exponents, top minus bottom. 6 minus 2 is 4. So I have 4x to the 4th. So that's going to cancel out those. And now over here, 3 goes into 9, 3. Well, that got rid of that. And then x squared, again, exponent minus an exponent. Let's see, 2 minus 2 is 0, so they're all gone. so there's no x's left. So 47, we have answer choice E. Okay, moving along. Let's see. Okay, now for 48, if we're doing matrix multiplication, now we really don't even have to multiply anything out here. Let's look at what we can do. In order for multiplication to be defined, we look at our dimensions. And the dimensions of a matrix, when you look at it this way, this is going to be your rows. That's rows. And then this way and this way, that's your columns. So when you write your dimensions, it's rows by columns. So let's look at W. The dimensions of W is going to be a 2 by 2. So that one's not too bad. And I'm just going to write it down here, 2 by 2. And then for X, the dimensions of, well, it's a 2 by 2 also. Let's see, what about Y? Now Y is a little different. Y has 2 rows still, so that's good. But the number of columns, you have 1, 2, 3. So it's a 2 by 3. And then for Z, let's see, with Z, you've got 1, 2, 3 rows. And you have 2 columns. Alright, so in order for us to be able to multiply matrices, we compare dimensions, rows by columns and rows by columns. And what has to happen for our product to be defined is the number of columns in the second, or in the first, number of columns in the first, has to be equal to the number of rows in the second. These two numbers right here must be equal. So W and X, well, no big deal there, 2 by 2 and 2 by 2, no matter which way you slice it, they're the same numbers. So it starts getting strange when we look at Y and Z. So let's pick off our answer choices. So WX, well, W and X have the same dimensions, so if we compare those, we would have a 2 by 2 compare to a 2 by 2. And notice these numbers are the same, so no big deal there. Well, what about W and Y? Okay, so let's look at W and Y and compare their dimensions. W and Y, again, this number here has to be equal to this number here. And it is. So W and Y are okay. We can multiply those. So not going to be G. Let's look at H, Y, and Z. So what about Y and Z? This number here has to be equal to this number here. It is, so Y and Z are okay. What about X and W? Well, X and W in order does matter, but they're both still 2 by 2, so it's not going to make a difference. So let's look at K, X, and Z. So X and Z. X is a 2 by 2. Z is a 3 by 2. Notice these numbers here are not equal, so we can't multiply them. So the correct answer choice here is going to be K. Okay, looking at number 49. Number 49, we're looking at a bunch of different parabolas here. And we need to know, well, which one of these for n greater than or equal to 1, which one of these could possibly be the correct answer? Well, let's see. A couple of things about parabolas. The first thing I would look for is the fact that you do definitely need to have x squared. And if it's not x squared, then you toss that out, which we do have x squared on all of them, so we can't get rid of any answer choices there. Now, x squared has to be positive because the parabolas are all turned upward. If it was negative, they would be flipped over. So it's not D and E. And let's see, right here, x squared, we need this n coefficient here. So for that n coefficient, it's not there, so C is gone. So Now we've got a pretty good shot at this. It's either A or B. So, we need to plug in either answer choices or try to go through some kind of reasoning. But if we start plugging in, we can see that in here, we're getting whole numbers in front. And so if we start plugging in whole numbers, what happens is my y values increase faster than what the original is. So if we're plugging in here whole numbers, whatever my x is, I'm multiplying by these bigger numbers here. So my y values are going up faster than they would here, because 1 over n is actually making those y values smaller. So that 1 over n actually makes our parabolas look a little bit fatter. They're flattening out. That's what the fraction does for us. Whereas the whole number, that's really increasing those y values, or making those y values go up quicker. So the right answer is A. But if you don't remember all that, at least have enough information you do to eliminate C, D, and E, and then you can take a better guess at it. Okay, number 50. So for 50, after polling a class of 20 music students, by show of hands, you can find that 8 students play guitar and 9 play piano. Given this information, what is the minimum number of students in this music class that play both guitar and piano? So this is kind of a tricky question in my opinion. You have a total of 20 music students. Well, you're looking at, where are really these overlapping? So if all eight students could technically play the piano, so really that would be a maximum though, because we could, but not all 9 piano players could be the 8 guitar players. We've got one too many, so 8 would be a maximum, but this is asking for a minimum. Well, I think it's tricky because you've got 8 plays the guitar, and then you've got 9 playing the piano. That's only 17 of the 20 students. So technically, you could have no students playing both, because here you've still got 3 students unaccounted for, and we don't know what those do. So based on just this information alone, what's the minimum number? I would say 0. So that's answer choice F, which, again, I'm not a fan of that question because I think it's misleading, but oh well. All right, 51. We're almost done. Number 51. A teacher assigns each of her 18 students different integer 1 through 18. The teacher forms pairs of study partners by using the rule that the sum of their pair of numbers is a perfect square. Assuming the 9 pairs of students follow this rule, the student assigned which number must be paired with the student that's assigned 1. Ooh. All right, so a perfect square, that's something we can take the square root of. So a good working list of perfect squares, well, 1's a perfect square by itself. Let's see, 4, 9, 16, 25, 36, and so on. So there's the idea of perfect squares. And we have numbers 1 through 18. So let's see, 1 through 18. So I would start with 18. What would 18 have to be paired with? Goodness. 18 students, 1 through 18. So 18, 17, 16, 15, 9, 8, 3. Let's see. Gosh, I would look at our answer choices, I suppose. And really, we're coming up with these perfect squares, 49, So paired with 1, has to be paired with 1. Nothing else is going to generate a perfect square. Let's see, what's our next perfect square? 64, let's see, 81, and then 100. All right, so let's see, what has to be paired with 1? So let's see, 16 could be paired with, goodness, 14. Let's see, and then there's what, 13, 12, 11, 10, 9, 8, 7, 6, 5, 4, 3, 2, and 1. And so they're giving us some answer choices to help narrow that down. So could 9 be paired with anything else and have, let's just start right in the middle. So what could 9 be paired with and we still get a perfect square? Let's see, 9 and 3 is 12, 13, 9 and 6, 54. Goodness, what could we put? 9 and, let's see, 9 and 7. What's 9 plus 7? 9 plus 7 is 16, isn't it? So 9 and 7 could technically go together. So it doesn't have to be paired with 1. What about 16? Let's try A. So 16, let's see, what could 16 be paired with? Well, 16 and 1 would be 17. That's not going to work. 16 and 2 is 18. That's not a perfect square. 21, 16 and 6, 22. Let's see, 28, 27, 26, 30, let's see, 8 and 6, 14, 34. Well, I don't think 16 has to be paired with 1 because that's not even going to generate a perfect square. So I wouldn't worry about that. 3, what could 3 be paired with to get a perfect square? 3 could be paired with 13. Let's see, 8. 8 might be trying here. Where could 8 go? 8 and 1, of course, but we're trying to see if there's anything else. Let's see, 8 and 11 is 19, 8 and 10, 8, 4, 8, 5, 8, 6, 8 and 18, 8 and 14. Well, does 8 have to be paired with 1? Well, let's see. 8 and 5 is 13. 8 and 5 is 2. So, let's see. Oh, 8 and 17 does 25. Goofy me. So, hey, that leaves us with B. It's going to have to be 15. 15 is not going to be paired with anything else. So, yeah, 15 and 1, that's going to give us 16. So that was a very time-consuming problem there. All right, so let's look at 52. See if we can figure that one out. All right, so let's see. Lucky found $8.25. So, and then she has pennies, nickels, and dimes and quarters. So, let's see. So she has pennies. And then she noticed that she had twice as many nickels as pennies. So her nickels, she has twice as many nickels as pennies. So I'm going to say 2 times P. I should even that out. And let's see, 1 fewer dime than nickels. So equals nickels minus 1. And 1 more quarter than nickels. So for her quarters, she had 1 more quarter than nickels. And so now we want to know how many quarters did Lucky find that week. So let's think about in terms of money, because we need to assign a value to this, and we also need to try to get this to talk about the same variable. So we can't make P talk about anything other than P. So let's see, nickels is already in terms of P. So let's make our dimes talk about pennies or in terms of P. Well, N is 2P, so I can make that substitution here and have 2P minus 1. And we can do the same for Q and have 2P plus 1. Now this is where it's going to get a little bit different because I can't just simply add all those up because these all have a value to them. And a penny, I'm going to go ahead and move my decimal 2 places to the right for all of this so we don't have to worry about those decimals. And if I do that, and then I start adding up our values, well, I know pennies, we just had P plus, and then nickels is 2P, but nickels are 5 cents, and I've already moved my decimal 2 places, so it's 5 times 2P plus, and I'm going to do the same for dime, so it's 10 times 2P plus or minus 1 plus, and then I've got to do the same thing for quarters, so it's 25 times 2P plus 1. And if I add up all of that, that's going to be her total deposit. And I'm just going to do 825 because, again, I've already moved my decimal for all that. So we need to go ahead and add up. Let's see, we've got P plus 10P, so that's 11P, plus 20P, so 31P. 31 and 50, well, that's going to be 81P. And now let's see about our numbers. We have minus 10 and positive 25, so that's positive 15, and that equals 825. And so let's go ahead and subtract our 15 over. So 81P equals, well, if I subtract that, that's going to be 810, isn't it? Well, that works out nice. So P is 10, so there's 10 pennies. And so now we needed to know, though, how many quarters. So we need to go back here and plug in. And so it looks like we're going to have 21 quarters. So 52 looks like it's going to be answer choice J. Okay, moving on. Let's look at 53. Now 53 always seems like it's going to be super tricky, but it's not, hopefully. With this one, we have to go back and remember our exponent rule, that if we take most things and we raise it to the 0 power, we do get 1. Now, I'm not going to say anything because not anything raised to the 0 power. It's not always going to be true. But for most of the time with what we're working with, yes. So the only way I'm going to say 10 raised to a particular power and get 1 is when this particular exponent, which is going to be this, is equal to 0. And that's because 10 raised to the 0 power is a positive 1. Well, with a fraction, the only way your fraction's ever going to be 0 is if you set the numerator equal to 0. So 2x minus 1 equals 0. And finish solving out this equation, we get x to be 1/2. So it looks like we have answer choice C. Okay, move. All right, so for 54, it looks like it's going to be a good probability problem. And let's see, what do we have here? A table below shows the results of a survey, 250 people. And they were asked whether or not they like to read and whether they play a musical instrument. According to the results, what is the probability that a randomly selected person who surveyed likes to read? Oh, and here's the biggie. Given that the person plays a musical instrument. When it says given that, that's the only place you can look. Only look here. And that's something that I think we miss a lot of times, so we can only look here. So given that the person plays a musical instrument, so we can only look in this list. Now, what is the probability then that the person in that list likes to read? So if they like to read, then it's 50 of the 90. So do keep that in mind. So we have 50 over 90. And so what is that going to reduce down to be? Because, and again, that's going to be your total amount of people that play a musical instrument, and then the top is the ones that like to read. So that's going to be 5 over 9. So that is answer choice G. Okay, so let's move over here to number 55. Hey, Mario was riding a bicycle with wheels 26 inches in diameter. During 1 minute of Mario's ride, the wheels made exactly 200 revolutions. At what average speed in feet per second? Oh, they're changing the units on us. In feet per second. So that means when we get finished with all of our calculations, our units must be feet per second. So at what average speed in feet per second was Mario riding during that minute? Ooh, we've got to do some conversions. So let's look at what we do know for sure. We had 200 revolutions in 1 minute. So I have 200 revolutions for 1 minute. All right. And then I've got to convert that because I don't need minutes. I need feet per second. So let's see. I know in 1 minute I have 60 seconds. So that's going to get rid of minute. So I now have seconds. And gosh, I know the wheels are 26 inches in diameter. And the circumference is pi times the diameter. So I know 26 pi. That's my inches. That's going to happen. That's how many times it goes around in 1 revolution. So now I'm moving away from revolution. And 26 inches. I need it in feet though. So I know that's inches. I need to write in inches there. And I know that there's 12 inches in 1 foot. That is a monster of a problem. So let's make sure our revolutions canceled, our minutes canceled, inches here canceled, inches there. So I do have feet per second. So let's list out what we have. I have 200 times 26 over 60 times 12. And we don't need to forget our pi. So let's see. Let's grab our calculators and leave pi in your answer. Notice that's what we're given here. And so we have 200 times 26 and then 60 times 12. So that's going to give us 65 over 9. And then don't forget to attach your pi. So really with this one, noticing your units and working toward that feet per second, that's going to be the best way to do these types of problems for sure. Okay, almost to the end. So 56 is a good exponent problem. And let's see, what are we given here? J and K are positive integers. Now, when we have square root of 3, we need to remember that that's 3 to the 1/2 power. That means square root. And j is already there, and so we're going to multiply those. Now 27 to the k, we need to get these bases to be the same, and 27 is really 3 to the third, and k is already there, so we're going to multiply them. And really we end up with 1/2 j equals 3k, because the only way these things can be equal is if the exponents are equal. And we want the ratio of j to k. So let's see, j to k, I would go ahead and let's multiply both sides by 2 to get rid of that fraction. So I have j equals 6k. So j to k looks like it's going to be, j to k is going to be 6, isn't it? So answer choice k. But do remember those square roots do imply that we have a 1/2 as our exponent. All right, a finite arithmetic sequence has 7 terms. So we have 7 terms. 1, 2, 3, 4, 5, 6, 7. And let's see. The first term is 3/4. Well, that's kind of weird. The first term is 3/4. What is the difference between the mean and the median of the 7 terms? It's arithmetic sequence, which means that you're adding the same amount each time. So you're going up the same amount. So since this is arithmetic and you're going up the same amount each time, the difference between the mean and the median of the 7th. So let's think about this. It looks like that if they're going up the same amount each time, the mean is the average and the median is the one in the middle. They're going to be the same. You're going up the same amount each time, so there's no discrepancy between the terms because it's all really consecutive, so to speak. And there's this equal amount of distance. So anytime that happens, the mean and median, the difference of those two, is going to be 0. They're going to be the same. Weird problem yet again. Okay, so number 58 is a pretty tough problem here. So in the circle we have, let's see, length of the radius is 4 and that side is 1, and we're looking for that particular arc. The length of BC is 1. Alright, so when arc ADC, so ADC is measured in degrees, which of the following expressions represents the length in centimeters of AC? So measured in degrees. Well, this angle down here, let's see what we do know so far about that particular angle. So this angle inside here, if we talk about that angle, then sine of that particular angle, and we're just going to call it A, angle A, how about that, equals opposite over adjacent, so, or I'm sorry, opposite over hypotenuse, so 1/4. So that angle is going to be your inverse sine of 1/4. So what's that going to allow us to do? Well, that's going to allow us to chop off some of these answer choices. So I know my answer has to have an inverse sine of 1/4 in it. So inverse sine of 1/4. So F is fine, G is not, J is not, and K is not. Right, so gosh, let's see. We need to talk about now Okay, so now we know kind of what that angle looks like. Now we need to know also, since we're talking about that arc, we need to know, well, what percent or some kind of, it said degrees of this out here. So we know that the diameter all the way across the circumference is 8 pi. But I want to know really, we need a percentage of that to 360. It told us degrees, so 8 pi over 360. Let's see, pi is going to be there over, how many times does 8 go into 360? Well, 8 goes into 36 4 times with 32, 40, so 45, so pi over 45. So that's going to lead us to here, F, because we need that percentage of the circle in degrees times this actual value here. And that one is a very strange problem. Okay, last two problems. 59 looks like a good plug-in problem. They give us some values here to plug in and a formula. The length of the triangle rounded to the nearest 0.1 centimeter. What is the area to the nearest 1 centimeter squared of the triangle? And they give us the formula 1/2 AB sine C. So let's see, 1/2 AB sine C. So let's see if we can't plug in 1/2. And now we need to figure out A and B. And it says note the area of the triangle with side lengths AB and C is the opposite angle measure. So sine of C, that's going to be opposite side C. So that's going to be here. So I have 1/2 4 times 8, order's not going to matter, sine of 30. And sine of 30 is 1/2. So I have 1/2 times 4 times 8 times 1/2. And so it looks like I'm going to get an area of 8. So here my answer is 8. Okay, and finally, number 60, woohoo! So what have we got going on with this problem? The probability distribution of the discrete random variable x is shown in the table below. What is the expected value? And expected value is starting to come up quite a bit on these tests. Expected value is not just terrible. You take your x value, which is your random variable x, shown in the table. The expected value is going to be the probability times this x value, plus this probability times that x value, and so forth. So to write this out, your expected value is going to be 0 times 1/6 plus 1 times 1/12 plus 2 times 1/4, and you can type every bit of this in your calculator, plus 3 times 1/12. This pen's not wanting to write. 4 times 1/12, and 5 times 0, and 6 times 1/3. And whenever you multiply and add up all of that stuff, and it looks like you're probably going to get answer choice. Let's see, what should it be? I think you're going to get answer choice K.